evening, students. This is a Vipin Purohit. Welcome you to all in online study of chemistry corners. So, dear student, today we will discuss ideal and non-ideal solution. In last time, we have already discussed the graphical representations of volatile liquids by the Rault's law. So, on the basis of Rault's law, we can classify solution into two subcategory. First one is ideal and other one is non-ideal. So ideal solutions, what do you mean by ideal solutions? So dear students, the ideal solutions or the solutions which obey the Raoult's law, over a entire range of concentration is known as ideal solution. Okay, what is ideal solution? Are the solutions which obey Raoult's law over a entire range of concentration is known as a ideal solutions. Other properties of ideal solution is, second properties of ideal solution is delta V equals to 0. Means if A plus B equals to solutions. Clear? And A is 20 ml, B is 50 ml, so the solution will be 70 ml. Clear? So dear students, this is initial volume, this is final volume. So dear students, V final minus V initial is equal to delta V. So if deduct the value of solute from the solution, we will get the value of solvents. This is the ideal conditions. Okay, this is the ideal condition. Suppose Vi, this is 70, well final volume कितना है 70, and this is the initial volume 20. So we will get the volume of solvents. This is delta V. This is ideal condition where delta V equals to 0. This is condition for ideal solutions. But it is not always possible in case of non-volatile liquid. So third properties of ideal solution is the total changes of enthalpy. Delta H is equal to changes in enthalpy. Changing in enthalpy. The value of delta H equals to 0. Means during the formation of solutions, the total amount of heat energy absorbed or the total amount of heat energy released is total value is 0, as same well as this one. So if delta H is equals to 0, then this is ideal conditions. Okay, second conditions, non-ideal solution. Non-ideal solutions, just you can say non-ideal solutions are those solutions which doesn't follow Raoult's law over a entire range of concentration. Means those solution which doesn't follow Raoult's law over a entire range of concentration are known as a non-ideal solution. Here the second property is the total changes delta V, means changes in volume. Delta V is not equals to 0. Third property, like to ideal solution, the total changes in enthalpy delta H, we have already discussed, is not equal to 0. Clear? This is the condition of non-ideal solutions. Clear? So why ideal solution, which one is ideal solution and which one is non-ideal solution? So dear students, non-ideal solutions further classified into sub 2 classes. So non-ideal solutions which doesn't follow Rault's law over an entire range of concentration. Means, suppose this is the case of ideal condition. This is ideal solutions, or just you can say this is condition of Rault's law. This line, suppose this line is the condition of Rault's law. Some solution which is deviated from positive, and some solution which deviated negative. Means this is the ideal condition. Suppose this point is 0 and this is positive way and this is negative way. So some solution which follow Rault's law over the point, standard point. Clear? This is positive deviation. Some solution which does not obey, absolutely not obey Rault's law at any range of concentration, this is negative deviation. So first of all we will discuss deviation. What do you mean by deviation? As you have already discussed in mathematics, deviation, the behavior from standard line. Suppose this is standard behavior, suppose this is ideal behavior, the behavior from the ideal line, either the upper limit, either the lower limits. This is deviation. Suppose this is positive deviation and suppose this is positive deviation, so this is negative deviation. This is negative deviation, this is positive deviation. So some solutions show positive deviation, some solutions show negative deviation. Let's discuss how some solutions show positive deviation, which solutions show negative deviation. So we will discuss positive deviation. Deviation positive. Clear? So positive deviation shown by those solutions positive deviations are shown by those solutions in which interaction between solute particle oblique solvent particle is greater as compared to solution. Means suppose this is solute and this is solvent, then formation of solution. Suppose solute is just component of A type of compound and solvent is a compound of BB component, then the formation of solution will be AB type of component, because we know very well the combination of solute plus solvent is the form of solutions. So here solute is AA type, this AA type is the formation of solute, this BB type is formation of solvents, and this AB, when solute and solvent will combine, then formation of solution, then the formation of solution will be AB type. Clear? So here I want to discuss here the intermolecular force between AA the intermolecular force between AA. Intermolecular force between AA particle or AA component is greater than AB, means solution. Clear? Or just you can say the BB, suppose in case of solvent, the BB component or the intermolecular force between this BB, the intermolecular force between this B and this B is greater than intermolecular force between A and B. Clear? Why? Because of suppose because of in volatile solutions, suppose this one is volatile and this is also volatile, but the solutions will be volatile, also volatile. Clear? Okay, so here the attraction force between AA is greater than attraction force of AB. Why? Here AA is same type of component and here AB is different type of component. So due to this we can say the attraction force between AA is greater than compared to AB. Or just you can say in other words, the intermolecular force between BB is greater than AB. Due to this, solution show positive deviation. For example, here the ethanol plus acetone is the example of positive deviation. Clear? So we will discuss further the graphical representation of positive deviation from the Rault's law. How it is possible? Let's see. Okay, here the graphical representation of positive deviation, how alcohol plus acetone show positive deviation. So dear students, as we have already discussed in previous lecture, the graphical representation of volatile liquid. So this is the PA, this is the PA, this is the PB, this is XA, this is XB. So here the student, this is origin of point XA equals to 0. This is the point where XA equals to 1. This is the point. Clear? So dear student, here the value origin of XB equals to 0. This is the origin of XB and here the value of XB equals to 1. Clear? So dear student, we have already discussed in previous video, previous lecture, this is ideal behavior from Rault's law. This is the clear. This is the ideal behavior. So dear students, this is the ideal behavior. We have already discussed in previous video. This is the value of P equals to PA plus PB. Clear? This is the value of PA is equal to P naught A XA. This is the value of PB is equal to P naught B XB. Okay, this is the value of P naught B. Okay, this is the value of, this is P naught A and this is the value of P naught B. First condition of Rault's law. This is ideal behavior. Suppose solution, if solution shows same type of graphical representation, means this is ideal solutions, and if solution doesn't show this type of graphical representation, are non-ideal solutions. So how, this is the, suppose this is the ideal behavior, this line is the ideal behavior. Okay, and the solution which show positive deviation from ideal behavior, this is the deviation from the ideal behavior. This is the deviation from ideal behavior. This is the deviation from the ideal behavior. Here the green pen is just represented at the positive deviations. Means what do you mean by positive deviations? Positive deviations means we have, this is ideal behavior, PA is equal to P naught A XA. This is ideal behavior. Ideal behavior. the partial pressure of solute is equal to P naught A and XA. Clear? But the positive deviation, so PA is always greater as compared to P naught A XA. This is positive deviation. Positive deviation. Clear? Same, PB is equal to P naught B XB. This is also ideal behavior. This is also ideal behavior. But the positive deviation is PB is greater than P naught B XB. This is positive deviation. Clear? So at last the final P equals to PA plus PB. The total pressure of solution is equal to total pressure of solute plus total pressure of solvent. This is ideal condition. Ideal condition. But P is greater than PA plus PB. This is positive deviation. Clear? So by the equation first, by the equation second, by the equation third, by the equation first this one, by the equation second this one, and by the equation third this one. This is the positive deviation. How? Let's check again in the graph. This is the ideal behavior. This is this line. PA is equal to P naught A XA is the ideal behavior. Okay, and here this is not ideal behavior. This represented by green line. Okay, the green line represent P is greater than P naught A XA. This green line represent here P is greater than PA plus PB. This green line represent this equation, while the black line represent P is equal to PA plus PB. So this is the upper side of the standard line, upper side of the standard line, and upper side of the standard line. So due to this we can say this is the positive deviation in the pie chart. So this is the positive deviation shown by solutions. Okay, now we will discuss about negative deviation shown by the solutions. So we will discuss negative deviation shown by the solutions. Negative deviation shown by those solutions. Those solutions show negative deviation in which the intermolecular force between solute oblique solvent is poor than that of solutions. This type of solution will show negative deviations. How? Again, let's see with the help of example. Suppose this is solute formed by the components of AA plus solvent formation of components of BB, and this one is solutions. Clear? The intermolecular force between AA and the intermolecular force between BB, intermolecular force between AA is poorer than that of intermolecular force between AB. Second, intermolecular force between BB is poorer than intermolecular force between AB. Now, what do you mean by AB? AB is solutions, intermolecular force between solution particles. Clear? And here AA is represent the component of solute, intermolecular force between solute particles, and BB represent intermolecular force between solvent. Clear? So this type of deviation shown by phenol plus aniline. Clear? Here this is the structure of phenol and this is the structure of aniline. Clear? And phenol, this is phenol, have two lone pair of electron, NH3 have lone pair of electron. Due to this, here lone pair repulsion force will decreases the intermolecular force. So here how we will represent by the graph. So the graphical representation or by graphical explanation of negative deviation. Clear? So dear students, we again take the example of graph by the Rault's law. This is the standard behavior. This is the standard behavior. This is equal to PA plus PB. This is PA is equal to P naught A XA, and this line is representing just PB is equal to P naught B XB. Clear? So negative deviation, this is the ideal behavior. This line, suppose this line, you know very well, this is representing here y-intercept, this is x-axis, this is PA, this is PB, this is XA equals to 0, this is XA equals to 1, there XB is equal to 0, here XB equals to 1. Clear? This is origin for XA, this is origin for XB. Clear? Here this is P naught B, here P naught A, sorry, this is P naught V, this origin. Clear? So negative deviation shown by solutions, negative solution are this is the negative deviation below the standard behavior of standard line. This is the standard below the behavior of standard line, and this is the behavior from standard line. So this is the negative deviation. Okay, negative deviation by the solutions.